Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss the concept regarding hydrostatic law. In our previous lecture, we have discussed about the Pascal's law. So let's discuss the concept of hydrostatic law. Hydrostatic law defines that the rate of increment of pressure is equal to the specific weight of the fluid at any point in a static fluid system. Or we can say the rate of increment of pressure is equal to the rate of increment of pressure which is moving in the vertical direction, downward direction, is equal to the specific weight of the fluid. Okay, we basically know that when a system, when a fluid, if you contains in a container, and if you want to measure the pressure of this fluid as per the depth or as per the height, you can say, suppose this is the container which is filled of water or any kind of liquid is there. Now if you want to measure what kind of pressure is there at different points, now what we can do, let do a holes here and here do another holes. Okay, so the flow rate of this liquid, okay, or discharge of this liquid, you can say the liquid which will come out from this, okay, you can see it's very small will be there, so that it will be fall down on this spots itself. But if you put a hole here or a little bit down, you can see the flow rate of this or the discharge of this liquid will become little bit more distance, and it will become with a high pressure, high speed. It indicates that if you go downward direction to this fluid in a container, okay, the pressure will be increased. Okay, here how much pressure is there compared to if you go downward direction, the pressure will be increased here. Okay, now this law states that the rate of increment of pressure is equal to the specific weight of the fluid and which is moving downward direction. That we need to prove actually. Okay, so for this I have taken a small container in which liquid is there, and in this liquid I have taken a small elements here. Okay, a small element I have taken here. Let me draw in this way. So this is the small element which I can draw here, and this is the a small size is there, that is ABCD, and this element is having a height of delta Z. Okay, because it is very small, so I have taken delta Z. Yeah, and this element is situated with a height of Z, from the liquid surface. Okay, height of Z from the liquid surface. Okay, now this element will be affected by the pressure at different sides. So we need to identify first what are the forces acting, or you can say what are the pressure we are giving on this all the sides. So for that, first we will do let's write the force acting on the element, the forces acting on the element at different sides or different surfaces, you can say. Okay, so first one, how many forces are going to act on this? Okay, let's identify that one. First one, I can say the pressure force, which is acting on side AB, you can say. See how many forces will be act on that. Previously also we have discussed regarding this. So one pressure force will be there, and one weight of the fluid element will be there. Okay, so the pressure force which is acting at the surface AB, that means this one, if you see a normal pressure which is acting on this, that is P. Okay, and when you go for the pressure force, when you calculate the pressure force on AB surface, then we can say what is the pressure applied on that and what is the area of this. And one more thing is there, the area of this fluid element, let's consider that is delta A. Delta A is the cross sectional area of this fluid element. Okay, so here we can write the P into A, that is delta A. Okay. Now, similarly, the pressure force which is acting, another one surface is there. So another one surface, that is let's consider DC or CD, the pressure force on CD. So as I told you, if you see this location, this path, this is at this height of Z, and now this location, CD location, is again one more height increase here compared to the first one. You see how much height is increased? The Z plus this delta Z. Okay, so that much height was increased from here to here. But then what about the pressure? So obviously pressure also is going to increase here. So what is the pressure of this point at the CD point? Now at the CD point, the pressure will be reverse direction. Okay, it will be vertically upward direction. So that means the fluid opposing, there is pressure opposing force will be there, which will be acted at this CD surface. So what is the pressure force will be there at this point? Now what force already there here? Okay, what pressure is there? That one, that is P plus dou P by dou Z, dou P by dou Z into, we can say, delta Z. Delta Z is the height of this, that much height, into the area. So area is same for that, so we can consider delta area is there for this. So how this dou P by dou Z came? Let's see. This is a small fluid element. Already I told you this is a very small element. Again, if you see the pressure acting on this each zone inside this, so you can say this layer of zone is there, and everywhere some pressure is there. Okay, with respect to some height. So each pressure, if you consider P1, P2, P3, P4, all these small pressure element which is acting here, if you consider that one, then we can derive in this way that dou P by dou Z into the delta Z height, total height how much. In this zone how much was there? In this zone how much? Total delta Z height how much was there. So that's why it can be written dou P by dou Z into del Z. Okay, so this is the pressure force on the CD point here at this point. Now third one, you can see the remaining surface is there. One more surface is there, AB surface. Another one is this CD surface, AD and BC surface. This AD surface and BC surface. At this point, actually, the pressure force which will be acting on this point, okay, in this side, so that will be equal and opposite. So the pressure force which is acting on AD and BC, so that will be equal and opposite. So it can be cancelled, so no need to consider this one. So but we know that there is a pressure force will be acting here because there is no gravity, no other pressure will be acting on this, so it can be equal and opposite. We can cancel that one. So this is one more. And fourth one, that what is the weight of the fluid element? So that is W, weight of the fluid element. We know that W we can write again mg, mass into gravity. So mass we can write rho v into g. This one we can write again. Volume place we can write rho into g. Whatever the volume, what is the height is there, and what is the area of this. So height we can say delta Z, and this is delta A. So these are the forces which is acting on this element, fluid element. Okay, now we need to equilibrium all these forces so that we can find out what is the pressure acting, what is the pressure formula for this here. Okay, now resolve the force, or you can say equilibrium all these forces, and we can write how many forces are there. Now first one, this let the forces which is acting on this AB direction, like AB surface in the vertical downward direction, let's write that one, that is P into delta A. P into delta A, which is acting on the surface. Now we can write the another one force which is acting on this, so that is nothing but this one. Okay, so that will be surface CD, so that will be reverse direction, that means vertically upward direction, so that will be minus of, we can write bracket start P plus dou P by dou Z into delta Z into bracket complete delta A. So this is the force which is acting vertically upward direction. Now these two forces completed. One more force I told you which is equal and opposite, that is neglected. And one more force, weight of the element. So weight of the element we know that always vertically downward direction. So that one also we can write plus rho g delta Z into delta A. So that equal to 0 we can write. Okay, that equal to 0. So here what we can do, we'll take this concept, this minus side, other side, and remaining term will keep in one side. So that means P delta A plus, okay, rho G delta Z delta A equal to P. Okay, here we can do one thing. We can elaborate this one. Then we can go for shifting to other side. Let's keep here minus P delta A, and here minus keep inside. So minus dou P by dou Z delta Z into delta A equal to 0. Now you can see this P delta A will be cancelled. Okay, and remaining term, these two terms will be there. This is one, this is another term is there. Now one more term is there, rho G delta Z. So that is already you have written here. This one, 1 2 cancel. Okay, remain 2 terms, correct. Now you can write rho G delta A and delta Z equal to dou P by dou Z delta Z delta A. Okay, now this delta Z delta Z we can see both sides, that can be cancelled. So we can get rho G equal to dou P by dou Z. Okay, so you can write, so dou P by dou Z equal to, we can write rho G. Rho G is nothing but specific weight or weight density of the liquid. So that's what the proof required for us. As I told you, the rate of increase of pressure or the increment of pressure is equal to the specific weight of the fluid. This is the specific weight of the fluid and this is the rate of increase of pressure. Okay, so this is the proof required for this. And again, we can write this equation. This is actually the hydrostatic law derivation and hydrostatic formula, this one. And also we can write this equation in other term. Let integrate this equation and we can get what we'll do here. Let keep dou P one side and integrate of this, and other side rho G, and this delta Z will come here. Rho Z will come here. Integration. This integration we need to consider 0 to delta, because the concept is here. What is the height? Like a 0 height is there. Here in the surface, if you see, there is no height is there of this liquid fluid element what we have considered. And what the height of this from here to here, that one we can consider 0 Z. So the upper limit, lower limit we can consider 0 to Z. And if you integrate this one, we can get P. Now here rho is constant, G is constant, density of the fluid. Rho we can take it outside, and that is dou Z integration, that will be Z only, and upper limit, lower limit, that will be Z. Z minus 0, so Z will come. So this one, if you see, this is the pressure formula for the liquid. Okay, so we can calculate the pressure value from this formula. And also if you want to write the value of Z, also you can write Z equal to P by rho G. P by rho G, and that one we know that is pressure head. That is pressure head. This formula actually, this formula we can identify in the Bernoulli's equation. While derive this Bernoulli's equation, we can get Z value. So I hope you understood how to derive this hydrostatic law and what is the concept of hydrostatic law. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.